Hi Math 10C, it's Mrs. Ricks here. We're going to go through lesson 5.5, graphs of relations and functions. So we can represent the function that associates every whole number with its double in several ways. So first we can use a table of values. So here's our whole number 0, 1, 2, 3, 4. It could continue, but we just stop it at 4 here. And then double the number y, 0, 2, 4, 6, 8. So we're going from this number here. 0, double 0 is 0, 1, double 1 is 2, 2, double 2 is 4, 3, double 3 is 6, 4, double 4 is 8, etc. So the table continues for all whole numbers. So remember the real number system, all whole numbers are 0 to infinity, no fractions or decimals or negatives, okay? The domain is the set of whole numbers. So every single whole number from 0 to infinity. And the range is the set of even whole numbers. So every even number from 0 to infinity. We can also represent this statement using a graph. So here's our graph. We start with 0, 0, we go over to 1 and 2, 2 and 4, 3 and 6, 4 and 8, and then they also show it here as an equation. Okay, y equals double x, y equals 2 times x. So we know the relation y equals 2x is a function because each value of x associates with exactly one value of y, and each ordered pair has a different first element. All right, so we can take a look at either the graph or even the table of values. That's what we looked at last week to show that it is a function. So we know it's a function because none of these numbers repeat in the x-axis or in the x column. The domain of a function is the set of values of the independent variable. For the graph above, the domain is the x value. So domain will be on the x-axis. And the range of a function is the set of values of the dependent variable. For the graph above, the range is the y values up here on the y-axis. When the domain is restricted to a set of discrete values, the points on the graph are not connected. So we talked about discrete and continuous data last week. So discrete data means that there's no data in between. So if we go up again to our table of values, there's no data in between 0 and 1, 1 and 2, 2 and 3, etc. So this is what we call discrete data. That's why this graph, this is why none of the points are connected, because it is discrete data. So a relation that is not a function, has two or more ordered pairs with the same first coordinate. So when the ordered pairs of the relation are plotted on a grid, a vertical line can be drawn to pass through more than one point. So when we draw, we can draw vertical lines through this grid. And if we start at this point here, there's only 1, 1, 1. Here we have 3. So because of that, that means that 1 on the x-axis is used more than one time, which means that this is not a function. This is not a function, okay? A function has ordered pairs with different first coordinates. So when the plotted pairs of the function are plotted on a grid, any vertical line drawn will always pass through no more than one point. So they're saying that this is a function, and we know it's a function because if I draw a vertical line through every point on the graph, I'm never going to hit more than one point. So this one here is called a function. Vertical line test for a function. A graph represents a function when no 2 points on the graph lie on the same vertical line. Place a ruler vertically on a graph, then slide the ruler across the graph. If one edge of the ruler always intersects the graph at no more than one point, the graph represents a function. So they're just saying to draw straight lines or use a ruler or use your pencil to go through every point on the graph, and if you only hit one point, then it is a function. Okay, let's keep going here. Example 1, identifying whether a graph represents a function. So we're going to use the vertical line test like we did in the previous question, and we're going to check. So which of these graphs represent a function? Justify your answer. So the first graph, I'm just going to start drawing a straight line through every point. So there's only one point there, and then look there, there's 2 points. So because of that, this is not a function. That's all we need is one. If the vertical line test doesn't work for one set of points. Let's check the next graph for world population. Again, if I'm just drawing a straight line through every point, it doesn't intersect more than one point, so we call that a function.